Failure mode and effect analysis is a structured and systematic process to identify potential result and process failure before have a chance to occur with the ultimate objective of eliminating these failures or at least minimizing their occurrence and severity. So it can be design FMEA or process FMEA. During design, it is advantageous to know how and where customer will use the end product, while process FMEA is performed to identify and address areas of potential risk within existing. Severity is a numerical measure of how serious is the effect of the failure, the measure of probability that a particular failure will actually happen. The degree of occurrence is measured on a scale of 1 to 10, where 10 signifies the highest probability of occurrence. Detection is the measure of probability that a particular failure or cause in our operation shall be detected in current operation and shall not pass to the next operation. Risk parity number it is a numerical and relative measure of overall risk corresponding to a particular failure mechanism and is computed by multiplying the severity, occurrence, and detection numbers. Risk parity number is a product of severity, occurrence, and detection. It provides prioritization of potential failure mechanisms. Normally, RPN values of more than 125 need a recommendation and action. The failure mode leads us to understand the effect, cause, and control, that is severity, occurrence, and detection, which help us to understand the risk priority number and action. Severity cannot usually be changed. Only revision of the design or process can be bring about a reduction in the severity ranking. Occurrence, design or process revisions and prevention can reduce the occurrence ranking. Detection can be reduced by instituting good detection. The identify the critical X is called the analysis, develop data collection plan and collect data, develop and analyze graphs, conduct hypothesis testing, that is to define the practical problem, convert the problem into a statistical problem, carry out and interpret a statistical analysis, and convert the statistical solution into a practical solution. It is claimed that the process has been improved in terms of yield by bringing a change in the important factor X. That is what's called as the hypothesis testing to see is there a real difference between process. For example, real question and statistical question. Real question, can we say that the yield of process B is greater than process A? And statistical question is that is there a statistical significant difference between the process mean of process B and mean of process A? Or is there is a difference in the mean just due to chance? That is what we call as hypothesis testing, and there are graphical techniques for this. Example, team performance. Then there is a normal test data. We have normal equal variances. ANOVA one way. Frequently asked questions such as why do we check whether the data follows normal distribution? What is Levin and Bartlett test for? What is ANOVA for? ANOVA is an analysis of variances one-way test to determine whether the mean of several groups are equal or not. Underlying assumptions of ANOVA, that is one way. Within each sample, the values are independent. The case samples are normally distributed. The samples are independent of each other. Levin and Bartlett test can be used to detect variances of several groups. Bartlett's test is for variances when assume that the data follows normal distributions. Then why do we check whether data follows normal distribution or because ANOVA way assumes that the data follows normal distribution, therefore we carry out normality test. Application examples include two sample t-test and ANOVA one way. Two sample t-test is the transition time taken on whether team A or B process the transition, but ANOVA is thus the mean time required to complete a certain task differ for the 3 levels of employee training. This is an example of a scatter diagram interpretation. Correlation analysis is the scatter diagrams of plots provide a graphical representative of the relationship of the two continuous variables. Correlation analysis measures the degree of relationship between the two variables. Regression analysis helps us to arrive at an equation to predict correlations.